So after knowing what polynomials are, there are a few other things that should be known regarding polynomials. Let us start with the basic thing, degree of a polynomial. What do we mean by degree in case of polynomials? Degree is nothing but the highest power of variables present in a polynomial. Right? I'll again repeat, the highest power of the variable in a polynomial is known as its degree. Now you know that in a polynomial the power of the variables can only be a whole number, right? So the degree is always a whole number. Let us take some examples. Say I have 4x cubed plus 9x square minus 2. What will be the degree here? See, the power, this x has a power of 3, this x has a power of 2. Highest power 3, so the degree is equal to 3, right? Take another example, say 4x square plus 9y cube plus 8z to the power of 7. What will be the degree here? Can you tell me? Again, the highest power of the variables present. X has a power of 2, y has a power of 3, z has a power of 7. Highest power present is 7. So the degree is 7, right? So I think you have a pretty clear picture. What do you mean by degrees? Consider another case. Say 4x square y cube plus 7 y cube z to the power 5 plus 19 x to the power of 3 y to the power of 8 plus 23 x to the power of 5 z to the power of 9. Consider this polynomial. First of all, is this a polynomial? Yes, it is, because each of the variables has a whole number power and they are joined using arithmetic operators. This is a polynomial, but what about the degree? See, in such cases, when one term of a polynomial constitutes of two different types of variables, we just add the total power to get the total value of the power for this term. Though it does not have any mathematical significance, we just add the powers for the sake of calculating degree. The power of x is 2 here, the power of y is 3 here. So 2 plus 3, the total power that I'll be taking for this term will be equal to 5. Right? Similarly, for this, the total power is 8. For this, it is 11, and for this, it is 14. The maximum value, 14. So the degree for this expression will be equal to 14. Fine. So in case if you have different variables in a single term, just add the powers of both the variables and hence you can calculate the degree in that way. Similarly, if I have say 32 x cube y square z to the power of 5, what is the degree here? Degree is nothing but the addition of all the powers. 5 plus 2 plus 3, that is equal to 10. This is the first thing that now we came to know about degree. Next thing that we should define is the term of a polynomial. What do you mean by term? See, term constitutes of two things, a constant part and a variable part, both multiplied together. A term constitutes of a constant and a variable. This constant part is known as coefficient of the term and this variable part is the variable. Say for example, say take this case 4x square. 4 is my constant part, x is my variable part. This became one term of the given polynomial, right? The terms are always joined using plus or minus in case of a polynomial, right? Say for example 2x to the power of 5 minus 3y to the power of 8 plus 7z to the power of 6. This is one term, this is another term, this is the third term of the given polynomial. The coefficient of this term is 2, the coefficient of this term is minus 3, the coefficient of this term is plus 7. Second thing is, terms can be of two types. One is like term and second is unlike term. So what do you mean by like term and what do you mean by unlike term? If the variable along with the power is same for two terms irrespective of its coefficients. I'll again repeat, if the variables along with its power is same for two terms of a given polynomials, or for any number of terms, if the variable and power are same irrespective of its coefficient, then they are known as like terms. For example, let us take few cases. 2x to the power of 5, 5x to the power of 5 minus 8x to the power of 5 are all like terms, right? An exact opposite is the case of unlike terms. If the variable is different or if the power of variable is different, then they will be considered as unlike terms. For example, say if it was 2x to the power of 5, 5x to the power of 7, or say 7y to the power of 5, these all are unlike terms, right? Always remember that though you can multiply a like term and an unlike term, but you can never add or subtract unlike terms. In order to do addition and subtraction, two terms should always be like terms. That is, the operation of addition and subtraction can only be performed on like terms itself. So I think you have a pretty clear picture what do you mean by like and unlike terms and what do you mean by degree. So in the next video, we'll be seeing the different types of polynomial, different classifications of polynomial based on degrees and terms.